minutes, but let's make them short. Okay, so here we go. Back to the second page of the PowerPoint. I want you to remember this label. Chemists are lazy. All we want to write is big M, but get yourself used to writing moles over liters when it comes time to solve problems. Okay? Get yourself used to using this label. Now what we're going to talk about is how much solid, most of the time it's solid, is in some liquid. And again, for us, most of the time it's water. How much salt was in that water? And how much? We don't have a balance that measures moles, so you know what's coming. We're going to have to do some grams to moles, and then you divide the moles by the liters. Okay, so that's how we're going to solve a few problems. Why? Because the label for molarity is moles over liters. Okay, what we're going to do is, again, solve for moles. Lucky for us, some of our problems give us moles right out of the chute, but some of them don't. We are going to give you grams. Ooh, convert grams to moles. We can do this. When solving, solve for moles and then separately divide by the liters. This is your pink sheet again. This is the pink sheet. No more 22.4. Erase 22.4 out of your mind. And that's the problem with the pink sheet, is that that's all it says, is 22.4. And now 22.4 moles over liters. We're going to change that number of 22.4 to whatever our problem wants us to do. Because the label for big M, is moles over liters. So if I give you liters, okay, and I give you a molarity, you can solve for moles. And here's what we're going to do today. We're going to stay on this side of the box diagram. Don't miss tomorrow. Tomorrow we're going to cross the box diagram, okay, and do that mirror image thing. But today we're just going to work on this side of the box diagram with our problems. Okay? Depending on what this little hint here is if I give you liters and molarity and you solve for grams, your given will be the box furthest away from the question box. We're going to do one of those. We're going to do, we're going to do one of these. And we're also going to do one of these. What's the molarity? So, we're going to start out with solving for molarity, and then we're going to use the box diagram. So that's why I'm going to get out of here right now, and let's jump to, let's jump to this sheet that you have, okay? Mine's a little messy. I'm just going to erase everything. Okay, so you have this exercise sheet, but let's start with the front. We're going to do some serious calculations here, and then, like I said, if there's time, I'm going to go back over station 5. Okay? Wow. I wish there was a quicker way to do that. But where we're at is that sheet you just stapled to. Okay, I'd like to look at the sheet you just stapled to your PowerPoint. And let's start on the front. Okay, let's start on the front. Mine's back on the document here. Okay, so we're going to start with arena. Yep, we're going to go around the room here and talk about what is molarity. Okay, so you saw that while I grab my extra. I'm done. I look through all mine. I don't have to. All right, arena number 1. What's molarity? I don't know. Okay, well, okay. No? All right, then let's start on the front. One more. Here we go. I'm going to hold these up like this. 2 beakers. Start on the front. Okay. Which one, arena, has the darker color? Okay, so call it the one on the left. Okay? Left. We're going to use it. Nate, number 2. Which one contains more solute per unit volume then? The one on the left. So you're writing that? Okay, that's what you'd be writing, Sarah. Okay, write the one on, for number 1, it's the left, and I'm going to hold them like this. Okay, what is meant by the term concentration then, Emerson? Take a peek up at the top of this sheet. Chemist needs to know how much, okay. What is concentration? Yeah? What's concentration? Big M means what? And what is the label? Moles over liters. That's what we're writing. Term concentration, you're going to write big M and moles over liters. Okay? Now, number 4, what factors do we have to consider when determining the concentration of a solution? Okay? Think of your box diagram for us. What do you have to think about when I want to know the difference between these two beakers? How come this one's darker? It's both copper 2 sulfate. How come it's darker?
It's got more higher concentration of copper 2 sulfate.
Okay, it's got higher concentration, and so it's got more moles. I don't measure moles on my balance. What do I measure? Grams. So that's what you're putting here. You've got to think about how many grams you put in, and you also have to think about how much. And what do we call that? Liquid. How much liquid? What unit is that? Volume. Good job, Grace. Okay, so that's what we think about. Now, number 5, when it's diluted, solvent is added to more concentration solution. How does the amount of solute compare in the initial solution compared to the amount of solute in the final? Okay, I just had water in here, Tracy, is what number 5 is asking. And now what it wants to know is when I have this one versus this one, what's the difference? No, they have the same amount of water, so what does it have more of? What does it have? Help her out, Michaela. What's the difference? I heard it over here.
Copper 2 sulfate.
Good, Spence. It's got more copper 2 sulfate. It's got more grams. Good job. Good job here. Whew. That was hard. Okay. Now, just to let you know, down on the bottom it says most common. So, looking at the bottom, that kind of summarizes what we're saying here. The most common measure of concentration is big M. You guys, you may not have noticed, but sometimes your bottles are labeled like 3 mole. No, they're never labeled 3. 0.1 molar HCl or 1 molar HCl. Okay. Today we're going to use 6 molar HCl in Chem 2. Okay. So that's our most common unit. You'll see percent. Now I know none of you know this. Okay. But just maybe you've seen it. What's the percent alcohol in beer? How much? I didn't hear.
Natty Light's 5%.
Okay.
It's 5%. Some are 2 and some are 5.
Okay. How do you know that, Emily?
Driver's ed.
Driver's ed. Okay, good answer. Good answer. Okay. That she never picks up a can and reads it. But yes, beer usually has 5%. That's what the rest of the world uses usually is percents. We use molarity. We use molarity. The rest of the world use percent. Easy calculation. I can show you how to do it, but let's just figure out how to do molarity first. Okay? So on the back, one more time. Back to you, Tracy. Numero uno. What's molarity? Moles over what? Liters. So again, big M is moles over liters. Okay. Here we go, Michaela. I'm going to give you grams, and I'm going to give you volume. Tell me, what's the box going to look like? Because that's how I solve problems. You're given grams, and we've got volume. Well, how am I going to solve for big M? Molarity.
Well, you have the volume, so you have your liters, so you just have to find moles.
So I just need to find moles, okay? And it says I'm also given what?
Grams.
Grams. So what do I do? So again, folks, use your boxes. We're going to grade that you have a box diagram. And today, this is where we're going to go. We're either going to use just those 2 or we're going to use all 3. Remembering that what I want in this problem is big M is the way to convert from moles to liters because that is what you told me in numero uno. That's the label for molarity. Okay, so we've got, what do I need to do then, Matthew? Michaela, help me with the box. Tell me exactly what I'm going to do. If I have grams, and volume. What am I going to do? What do I do first? So I can get big M, which again, get yourself used to writing moles over liters. What do I do?
Write down the given one.
Which would be what? If I give you grams and volume, what should I do first, knowing I want moles over liters?
Space, moles.
Okay? I think Jared wants to help.
Convert the grams to moles.
First things first, folks. If I want moles over liters, what you're going to write here is convert grams to moles. How do I do that? What do I use? What reference? PT. Good. Periodic table. And then, going back to that other slide, once I have moles, divide it by liters. Let's do it. Okay? Talk, talk, talk. Let's do a problem. Number 3. Calculate big M. Now, blank, big M, but again, I always write moles over liters, so I know what label I'm looking for. It's very important to know what label I'm looking for. In my given here is 0.50 moles of magnesium chloride. Okay, oops, forgot the 2. And that's dissolved in to produce 1.5 liters of solution. Folks, this is what I do. Write that, and I draw my box. Okay? Right away I'm going to draw my box. I got to draw it up here so you can still see the problem. I'm given moles. I'm given a volume. I actually put my numbers in the box. So that helps me see, oh, okay, that's the info I'm given. This was the information I'm given, okay? Now how do I solve? Okay, Matthew, how do I solve this easy sneezy problem? I'm given moles, I want moles over liters. I have moles.
I'm still.
How do I get moles over liters?
Multiply by moles over liters.
Okay, no, I have moles. Want to help him out, Taylor? What do I need to do? You bet. Okay, all I need to do on these easy sneezy 2-box problem like this is take your moles and divide it by your liters. Okay, look at the label. I'm going to have moles over liters.
Wait, what does that label say?
What's that?
What does that label say?
Liters. That's a liter.
No, above.
Moles of magnesium chloride.
I thought it said milliliters.
Okay. Okay. Good job. Here we go. Final answer. Got to get those calculators warmed up today. Got to get those calculators. 0.50 divided by, what did you get? 0.3. Now careful, sig figs. Good. 0.33 big M. You like these problems. That's the easy ones, right? Those are the easy ones. Number 4, though. That you're going to get maybe one of those. Okay? Let's get real here. IV solutions. I don't know if you've ever been in the hospital, but if you're going for surgery or you're dehydrated, first thing they do is hook up an IV. Most of the time it's salt. That's what they're throwing into you. You get your salts off balance. And so I'm reading this is often so. IV solutions administered in the hospital. Normal saline contains, I draw the box right away and put my numbers in. 0.90 grams of NaCl, okay, in exactly 100 mils. Now I know I can't go from grams to milliliters directly, okay. I have to go, and I'm going to move this, okay, move this down so we can work it. Okay, I like to work it so we can see here. Okay, this is going to go, I can go grams to moles. And what else did the problem give me? It gave me 100 milliliters. Then, okay, what's it asking for? What's it asking for here? Molarity. Back to you, Matthew. I'm not going to let you off the hook today. What's the label for molarity? I'm looking for molarity, but what's the label?
Capital M in parentheses, moles.
Moles over liters. Okay. Okay, so now to you, Caitlin, where should I start?
Is this still under 4?
This is all 4. I just don't have room there.
You should convert the grams into moles.
I should convert my grams to moles. So, again, label of my final answer is moles over liters of NaCl. And my given, Caitlin said 0.90 grams of NaCl. Okay? And how do I do that, David? Grams are given. Where do they go?
On top.
Okay, they're given. So in order to cancel on my conversion factor here,
Use periodic table.
use the periodic table. How much is it? I need to know. How much? Who's got it?
58.45.
That's it. We've used it a lot, right? Did you memorize it or did you just?
I remember Na and Cl.
Yeah. Good job. 58.44 grams of NaCl. And where should it go, David? Top or bottom? Where should grams go?
Oh, on bottom.
On the bottom. And 1 mole on the top. Okay? At this point, grams will cancel. I will have moles, which is what I want in my numerator. So Aiden, what do I do next?
You divide the moles by the liters.
And how, okay, so it's 100 milliliters. That's not the label I want. I don't want milliliters, so what do I need to do with those milliliters, Cody? Milliliters to...
Liter.
And how do I do that? How many milliliters are in 1 liter? Milli means how many? Not 100. That'd be a cent. What is it? How many? 1,000. Okay. I am a very lazy chemist. So as soon as I see milliliters, I go boom, boom, boom. And I get those to liters. Okay? It's the same as this, so write that down so when you're doing your homework tonight, you'll go, how did Misery do that now? She just moved it over. Okay, that's what you do. This is the same. So really, okay, it's dividing by 0.1, isn't it? Okay? So take our answer here, 0.9, and like we said, divide by that 58.44, and then divide that by 0.1. And what do you get? Anybody?
0.15.
I get that too. That's the answer, folks, that belongs over here. 0.154, because they're, oops, careful, Grayson, you and I did that wrong. Okay, what should it be?
0.15.
It's only 2 sig figs, am I given?
0.15 is it?
How, point what?
0.15.
0.15, thank you. 0.15.
May I ask what's the stuff on the bottom?
Yeah.
What's what stuff?
Well, I don't know if you moved it down. It's supposed to be off to the right part of the equation, or if it's down there.
Here, I'll get you a new pay. We'll do the net, okay? It was like this, okay? It was grams to moles to liters, right? And the given was grams times grams on the bottom, moles on the top. And we divide the whole thing by 0.1 liters.
Oh, okay.
That's how you do it. It's that simple, okay?
I did it now.
So, that's how we do it. Let's do number 6, and I'll do it too the same way here, okay? Let's see, or number 5, right? We're on 5. I'll do 5 here,
There's
okay?
no code for this. We don't need to save this, do we?
Pardon me?
There's no code for this. What do we do?
It's supposed to be stapled to the PowerPoint. All right, number 5. How many grams? This is what I do right away. How many grams of HCl must be used to make, ooh, there's a volume number. And again, I change it right away to liters. It was 350 mils, so 0.350 liters. And it said now I have a molarity. And again, I'm not just going to write, okay, I'm not just going to write big M. I'm going to write moles over liters. So this is number 5. Okay, this is number 5. And so the question is how many grams? Okay? Emily, or Sarah back there, what's missing? What's labels missing in this box? Moles. Okay? I'm missing moles. So now, Emily, which side should I start on? Should I do anything with grams, or isn't that what I'm solving for? So where should I start with this problem? With what? Liters. Now, sometimes some of you question, should I use molarity as my given or volume? No, folks. When you have a volume and a molarity, use molarity as the conversion factor. If I give you grams and molarity, use molarity as a conversion factor. What's in the box should be your given. So here we go. 0.350. This is now liters. I changed it right away. Times, using molarity as a conversion factor, don't just write big M. Jared, am I going to use molarity straight up, or do I need to invert it in order to get liters to cancel? Do I use moles over liters or liters over moles? Folks, you can do whatever you need to in a problem. What do I use? In this one, I've got liters in my given. Where should they go here?
On the bottom.
On the bottom. So what goes on the top?
Moles.
Moles. Now, here's the question, Taylor, is where does the 3 go? Does it go with the moles or the liters?
Moles.
Perfect. Keep the number with the moles, because we keep saying moles per liter. We're implying it's 1 liter. Moles per 1 liter. So good job, Taylor. The number sticks with the mole. The number sticks with the mole. Okay? Here I am. Liters have canceled now, Spencer. What's my next conversion factor? If I have 3 boxes, I have 2 conversion factors. There's one.
Grams over moles.
Grams over moles. And so, how much, okay, is 1 mole of HCl? How much is it mass? Chlorine's 35.5. And hydrogen's 101.
That's 36.6.
There we go. Okay, so what do we get? Mine's messy.
36.
Okay. 36.5. Close enough. Okay. Grams, folks. I know that's kind of messy because I run out of whiteboard space because my givens are too big. Okay, so here we go. You take 0.350 times 3 times our 36.51 divided by nothing, right? Because it's all ones. It's all ones in the denominator. What's my answer here? How many grams should I throw into some water?
38.
38. There were 3 sig figs there.
0.3.
Okay. Why did I get 5? You're right. 38.3. Okay. That's game, set, match. Go ahead. Yep. All right. Let's go to your homework here. Okay. Let's go to your homework. And let's help you do some boxing.
Let's read.
What? Yep. Question? Yeah.
Yeah, if your given is moles, the moles will go on the bottom. Does the number still stay with the moles, or does it go with the liters on top?
Give me an example. What do you? Okay.
Let's say we had 3.5 moles
All right. So you have 3.5 moles
as our given.
as our given. And what am I solving for?
Grams.
And I want to go to grams. That's all you do. That's how
So
you do.
we would be we have the times.
3.5 moles. The moles got to go on the bottom. So grams go on the top.
Wouldn't liters go on the top?
No.
If we're
Okay.
given molarity.
Let's do some problems that we got here. Okay. Let's do what we've got. Okay. Which one? 2? No. 2. I'm just going to help with boxes. So first things first. Numero uno. Okay. Numero uno. We're to Grayson. What's the molarity? If I have 1.25 grams and 1, you're right, it's 125. Number 1, back to number 1. because we want to know. Here's the box. It says I have 125 grams of my bleach. That's the formula for bleach. And it says what's the molarity if I have 2 liters.
2/1.
Okay, well, what's my boxes? Let's get boxes first. I have grams
Moles.
to moles and up to liters. Okay? And what goes in the liter box? 2.0, right? Wasn't it 2.0? So we keep track of our sig figs. Okay? And what am I looking for? What am I looking for? Good job, Spence. You're really on top of this. You're looking for molarity. Okay? You're looking for molarity. So now what, Josh? Where should I start? Good job. You start at the box furthest away from what you want to find. I don't want to start with liters because I can't get down to moles when I'm looking for that. So we're going to do that just like our other one. Take your grams, 125 grams of bleach, and get them to moles over liters. And so how do I do that? Grams to moles. And then, okay, I want to get rid of that. Okay. And then I'll have moles on the top. So, and grams on the bottom. Grams will cancel. Then what? What do I do, Jake?
Divided.
By 2.0 liters. Good. Okay. Let's do number 2. Jake was questioning what's the box look like for 2. Okay. Octavia, what am I looking for in number 2? It says what? What am I looking for?
Liters.
Octavia? Liters. It says how many liters of 2.5. As soon as they start throwing numbers at me, I do my boxes. What have I got here? Okay. I don't know my liters. They gave me 2.5 big M, okay, of this acetic acid. And they didn't give me moles, but they gave me grams. So get rid of that. Move that down. Okay. So they gave me here that I have 256 grams of this stuff. CH3COOH. So, where am I going to start? What's going to be my given, Octavia? Grams or molarity? What should I use? Okay. No. We always use, if we have something in the box, use the box and use molarity as a conversion factor. So, what should I use as my given? Grams. So here's how you're going to solve that one. It wants to know how many liters, and you're given 256 grams of CH3COOH. So, grams to what, Arena? What am I going to do first? Grams to moles. Perfect. Okay. Grams to moles. Then use molarity as a conversion factor. Now, grams got to go on the bottom, moles on the top. This is where the whiteboard lets me down here. Is my next conversion factor. Where do moles go, Nate? Where do moles go? Moles are in the top here. I need to get to liters. They got to go on the bottom. So moles go on the bottom, liters on the top. Wow, am I messy. Okay? And so, where does the 2.5 go? It goes on the bottom. Okay? I'm sure you're going to have a few questions. I'll be around tomorrow morning. Okay? Stop in. Get some help. Check some answers. Yes. 1 through front is due tomorrow. 1 through 5. Pardon me?
Email you for the answer?
I'll upload it. Did it turn out?